Hello students, this video is about functions, pretty much just parts of functions we're going to talk about, and then some of the notation on describing those parts. So before we get to function, we start with relation. Well, a relation is any set of ordered pairs x, y, such as this. And all these points together make up a relation. The brackets mean set, so this is the set of points. Okay, now if we look at those points, they break down naturally into the domain and the range. And so let's describe those next. There's a bunch of different ways to describe domain and to describe range, a couple different ways to think about them. One of them is that the domain is just the set of all the first numbers. Okay, all the first components make up the domain, but a more mathematical way of saying that would be the first numbers here are all the x values, right? So the x values are our domain. The domain is also, as far as a function, the input values, the values that you're choosing, the numbers that you plug into the function. Those are the domain. So these are the input, and since they're independent because they're the ones you're choosing to put in. Okay? Okay, and then lastly, let's just give an example. So the domain from this relation would be 0, 10, 20, and 30. Good. So let's compare that to the range. So if the domain is all the first values, then the range is all of the second ones, all the second components. Okay, and the second components here are the y values, aren't they? So the domain is the x values, the range is the y values. And the range are the numbers that we get as the output of the function. So we choose our independent variable, the x numbers are the ones you choose to plug in, and then the range are the dependent, they depend on what you choose for the x. You plug in and you see what you get, and that what you get is part of the range. They are dependent. Okay, and like I just said, they're the output. And looking at our example here, the range would be the 9.1, 6.7, 10.7, and 13.2. Okay, so now that we have relation defined, some relations are functions and some of them are not. So how can you tell if it's a function? If it's a function, then every x has only one y. Every x goes to a y. The same x can't go to two different y's. It can only go to one y. So there are no double x's. Good. So if you had something like, so that would not be a function, right? Because the 2 goes to 1 and then 2 goes to 0. The 2 can't go to two different things. All right. So now what would that look like if you were to graph this? It's not a function. Well, the point 2, 1 and the point 2, 0 are 2 points that are right on top of each other. Okay? So not being a function with numbers, we can also use the vertical line test to tell if it's a function. If a vertical line crosses the graph at more than one point, then it's not a function. Okay, so here are some more recognizable graphs. Are they functions? Well, this one is a parabola, isn't it? This is the graph of x squared. It is a function, yes, because if I draw a vertical line, it only crosses the graph once. This would be more like the graph of square root of x, okay? And it is not a function, right? Because a vertical line crosses it here and here. Okay, here we have a circle. Okay, we have a circle. No, circle is not a function because when I draw a vertical line, it crosses more than once. And here I have something that has, this is like a graph of x, 1, 2, 3. This is like x to the power of 3. And this one is a function because a vertical line will only cross it once. Okay, let's look at this. What does this mean on the graph? If I have this section, I know that this section means that the graph does not extend past these 2 points. It starts here and it goes to here and stops. An open circle means that the point A is not included in the graph. A closed circle means that the point B is a part of the function. And then here we see that C, from the point C, the graph is extending indefinitely, unlike here. Okay, so now how do we say those things in interval notation? In interval notation, this segment could be written as, this means the interval from A to B, okay? And we can see that the point A is not included because of the parentheses here. And the bracket means that B is included in the set. Over here we would say that this is the set from C on to infinity. So starting with C, and C is included, so we have a square bracket, all the way to infinity. Infinity, we're going to have a parenthesis because you cannot include infinity. Infinity is too big to put a cap on. You can't cut that off, so we have to put a bracket. You don't include infinity. So in set builder notation, we are going to have the set, okay, so we have a bracket for set of x's, okay, and then we have a line that means such that the value for x, a is smaller than the value of x, and that x is smaller than the value of b. Now, we're going to put a line underneath this one because it can be the value of x is less than or equal to b. So when we have a colored in dot, this one means equal to, and when we have an open dot, this one is just less than but not equal to. Okay. So again, we have the set of x such that the value of a is smaller than x, but the a value of a is not included. And x is smaller than or equal to the value of b. And for the other one in set notation, so this means the set of x such that x is greater than or equal to c. Okay, so now what are the types of things that I'm going to want you to be able to do with this information? Well, first of all, when you look at a graph, I want you to be able to tell, is it a function? Is this a function? Well, in order to tell if it's a function, you have to think to yourself, vertical line test. Okay, let's see if we can find the value at f of 2. Okay, it looks like the 2 is on the inside of the brackets here. That means that the value of x has been replaced with a 2. So that means that we're going to go to our x-axis, and we're going to have to find the place on the graph where the value of x on the x-axis is equal to 2. So we're going to find the value on the x-axis, and here I see that x is 2 is right here, and coming up to the function, I can see that I have a value of 1, 2, 3, 4, 5. So f of 2 equals 5. For what value of x is f of x equal to 6? Well, f of x is the value of y. So this is like the y. I want to find out when is y equal to 6. I'm going to find 6. In order to do this, I have to find 6 on the y-axis. I'm going to come to the y-axis, and 1, 2, 3, 4, 5, 6. So it looks like the value at 6 is right here at x equals 1, 2, 3. So x equals 3 gives me 6. When it asks you to describe the trends, I want you to tell me where the graph is increasing and decreasing. And it looks like the graph is increasing on the interval from here, increases till it gets to the max up here. Okay, so we're increasing from 1 to 3. And then we're decreasing from 3 on down when we have an arrow, which means it goes on forever. So I'm going to use my infinity sign for that. So from 3 to infinity, it is decreasing. All right, now let's see if we can describe the domain and the range. Well, the domain is the x values. So for my domain, I'm going to use, okay, and I'm going to see what values are covered on the x-axis. Well, it covers all the way to this side, starting at 1, everything greater than 1. Okay, all of that is covered in my domain. So my domain is going to be 1 on to infinity. What about my range? For my range, I have to see what the y values are covered. So now I'm going to look at my y-axis. Well, the lowest it goes here is 2, right? But then looks like this arrow means it's going to continue to go down. So my range is going to go down all the way to infinity. But how far up does it go? It looks like the highest it goes up here is to 6. So I'm going to have everything from 6 and then the smallest being negative infinity. So my range is going to be, okay,